The presenter continues with a brief timeline of invention and launch. The S10 Ultra first appeared publicly during 2024-2025 product previews and crowdfunding activity Kickstarter, with wider press and market introductions during early 2025, including press notices around the Germany debut, so its invention is recent, the result of iterative engineering in 2024 and formal launch activity in 2025. The speaker notes that the product's world first positioning, the WaterRecycle System, as a marketing claim backed by engineering demonstrations rather than decades-old academic work. The team integrated water condensation, wastewater distillation and filtration, and automated chemical dispensing into the docking station to achieve continuous clean water operation. Moving into the heart of the talk, features and specifications, the expert lists what most users notice first. The S10 Ultra is a combined vacuum plus roller mop floor washer with a large multifunction base station. Key advertised specs include strong suction. The product page and reviews quote figures in the neighborhood of 13,000 pascals for the S10 Ultra, a self-cleaning and self-drying UltraReach Roller Mop, a water recycle station that auto-refills by condensing air moisture and distills wastewater, a sizable auto-empty dust bag in the dock, dToF LiDAR navigation, Apex Vision, dual 3D structured light sensors for obstacle recognition, AI anti-blockage and dirt-focused cleaning strategies, DirtScan, app and voice control, and support for both 2.4 GHz and 5 GHz Wi-Fi. The base station is presented as an all-in-one hub, emptying, washing, drying, and water management. These combined features place the S10 Ultra in the premium consumer segment. Describing the physical body and materials, the expert explains that the robot itself follows the common circular chassis used in many premium vacuums but pairs that with an extendable or low-profile roller mop assembly rather than a simple flat pad. The outer shell appears to be engineered ABS or similar high-impact thermoplastic with matte finishes for consumer aesthetics. The docking station is a larger molded enclosure that houses multiple tanks, clean water, wastewater pumps, heating and drying elements, filters, and the dust collection bag compartment. Internal components include stainless or coated metal rollers and mounts where durability matters, and rubberized sealing where the system handles water. While 3i's product pages do not publish an exhaustive bill of materials, the visible design decisions emphasize corrosion resistance in wet pathways, replaceable mop rollers, and modular filter dust bag access for maintenance. On how it works, the presenter gets technical but keeps it approachable. Navigation is driven by dToF, direct time of flight, LiDAR combined with dual 3D structured light sensors. This lets the robot build detailed maps, detect obstacles including low objects and small trip hazards, and plan efficient routes. For cleaning, a high-suction vacuum motor draws debris into the robot's collection bin. When mopping, a powered roller mop spins and wipes the floor while the dock handles washing and drying. The WaterRecycle System is the headline innovation. The dock distills or treats used mop water, routes wastewater into a sealed dust waste compartment, and, critically, can top up the clean water tank by condensing moisture from the air in some environments, essentially an on-device atmospheric water condenser dehumidifier function. Pumps, valves, and filtration stages and reportedly ionized or purified water processing on some models maintain, always clean, mopping water. AI features manage suction and mop pressure, adapting to carpets versus hard floors, detect blockages via torque current sensors, AI anti-blockage, and automate where extra suction or extra water is needed using DirtScan algorithms and onboard sensors. Actuators include brush motors, roller motors, vacuum blower, wheel motors, and electro valves in the dock. All these systems are coordinated by the robot's embedded control board and cloud-connected app for user personalization. When the expert addresses price and estimated cost, they speak plainly. At retail, the S10 Ultra sits in the premium price tier. 3i's site and listings have shown promotional prices around $1,199.99, with higher list prices reported in some regions near $1,899.99, while early Kickstarter backer pricing and regional launches may vary. The high price reflects the complexity and materials of the docking station, water handling hardware, pumps, heaters, condensers, filters, and a large dust bag mechanism, plus the sensors and motors inside the robot. The presenter cautions that final street price will vary by market, distributor margins, and whether the product is offered with bundles or subscription consumables, dust bags, filter replacements, cleaning solution. Next, the expert confirms the country of origin. 3i is a company operating from Shenzhen, China, and the S10 Ultra is developed and manufactured out of that ecosystem. Shenzhen and the surrounding Pearl River Delta are hubs for consumer robotics and appliance manufacturing, which is why 3i leverages established supply chain partners and PICEA's manufacturing backing. The product's European launch events and distribution simply reflect market rollout strategy rather than a different manufacturing origin. Shifting to broader significance, future benefits and applications for humanity, the presenter speaks with measured optimism. If a robot can manage its own water, filter, dry its mop, and recycle water efficiently, that reduces household maintenance time, decreases water waste when compared to frequent manual mop changes, and lowers friction for maintaining hygienic floors in care facilities, small businesses, and homes. In places with limited plumbing access or for mobile living arrangements, the ability to condense ambient moisture into usable clean water for mopping could be transformative for autonomy of cleaning appliances. For commercial or semi-commercial contexts, small clinics, daycares, rental properties, automated, hands-off cleaning that maintains hygienic water could improve sanitation and free human labor for higher-value tasks. The speaker adds that these systems also push the industry standard. Competitors will be motivated to improve water handling, filtration, and base station automation, which raises overall consumer expectations for zero-touch maintenance. The expert then shares a few lesser-known or hidden facts that don't always make headlines. The WaterRecycle claim rests on multiple subsystems working in concert: condensation, which is humidity-dependent wastewater treatment, filtration and distillation steps, and careful sealing to prevent cross-contamination, so real-world performance depends on local humidity and maintenance of filters and cartridges. Some early reviewers note that the condensation top-up works best in more humid climates and will be slower in arid conditions. Likewise, the system relies on replaceable consumables, filters, dust bags, possibly purification cartridges to maintain water quality long-term. Additionally, because the dock contains pumps, heaters, and condensers, it's physically larger and heavier than simpler auto-empty docks. That trade-off is why the S10 Ultra is a premium, station-heavy design. Finally, while the marketing calls it world's first for WaterRecycle, the expert cautions that first is a competitive marketing claim and the true novelty is integration and consumer packaging rather than a completely unprecedented physical principle. Looking forward to possible future developments and impact, the expert sketches plausible directions: improved atmospheric water capture efficiency allowing reliable top-up even at lower humidities, tighter integration with home dehumidification systems, turning dock stations into small-scale home dehumidifiers, broader sensor suites for biohazard or allergen reduction, UV or hot water sanitization cycles at higher temperatures for deep cleaning, and more modular base stations that combine robotic laundry, dish, or surface sanitation in multi-appliance hubs. On the software side, advances in on-device AI will let future models better identify surface types, predict soiling patterns, and schedule targeted deep cleans without user input. The presenter closes by saying that products like the S10 Ultra push household robotics from nice to have to time-saving essential for busy households and care settings. If reliability and maintenance costs stay reasonable, the category's impact could be greater workforce substitution for repetitive cleaning tasks and measurable improvements in domestic hygiene. Finally, the narrator signs off with a practical note about buyer expectations. The S10 Ultra offers genuinely novel conveniences, automatic water management and a highly automated dock, but buyers should weigh the premium cost, potential ongoing consumable replacements, and environmental conditions, humidity that affect some water recycle features. For content creators or engineers watching this product class evolve, the takeaway is that 3i's S10 Ultra is as important for what it attempts closing the loop on mop water as for how successfully it executes that attempt in everyday homes. The expert leaves the audience with the image of a future where a robot vacuum doesn't just collect dust but manages its own water cycle, ordinary household chores receding further into the background of daily life.